from a cellular PVC point of view, the products that seeing in the market will all use just a foam PVC core to varying degrees. Some of the issues that have come up are enhanced or exaggerated expansion and contraction relative to the polyolefin material. And again, inherently foam PVC does want to expand more. That's also something I'll get to in the numbers, that we've put a lot of energy into solving with a core. So currently, our expansion and contraction coefficient on this is 4.2 times 10 to the minus 3. So it's about 20 to 25% less than infinity, when inherently most of them are higher than polyolefin materials. Okay, so this will expand less. It still expands and contracts, but less than the infinity material. From a cap point of view, all capping, I can't say all, most capping in the industry has been PVC-based capping. Now, PVC is inherently, as a material, not stable from ultraviolet. If you ever see a pipe like, drain pipes and things like that, they're normally blue or black in color. You see them arrive at a construction site and they sort of sit outside for, a month or two, and you see them go white. So PVC naturally is not stable, and it is very difficult to stabilize PVC from ultraviolet, because it's not only the additives that count, of course they count, but you also have the mechanics of your production. So it's a full turn system with PVC production that really gives you the stability of the cap, and it's quite difficult to achieve. So, I think in the US now, the market is pretty much consolidated around probably AZAC, owning the lion's share of that market. They've been doing that for, over 20 years now. They really have got their PVC cap and their system right, but for the most part, entrants into that space don't really make a good go of it. With the acrylic material that we're using, again, inherently, this is a great material for outdoor use. The main applications of acrylic are in automotive. So BASF developed this material in the late 80s, early 90s, and they specifically developed this material for automotive application. So if you look at, say, the side view mirror casings of an automobile, a new automobile today, generally that material is ASA, it's acrylic material. They often use it on, bumpers, parts, plastic component parts that are exposed to the exterior of the vehicle. It's a very hard material, so from a scratch point of view, from an impact point of view, it really performs extremely well. It's a very robust material. It's more kind of a super plastic, if you will. It hasn't been around too long, but it's a super plastic that they've, put together to have features that are above any other polymers for outdoor applications, that were in place before, the late 80s. So I think the 90s, late 90s, this material really started to take off in the automotive sector, and today is a big plastic in automotive. From a cost point of view, this material is significantly more expensive than a PVC material. So, I understand why people try and do it with PVC, but the aesthetic on PVC is, there's some drawbacks there, some limitations there, and then there are also complexities in putting the material together. Another real driver for us in going acrylic is that in Europe, PVC within for sure the next 5 years will be banned for construction materials, completely banned. Okay, so at the moment it's also kind of frowned upon, so people are not, too interested in starting new businesses in construction products in PVC at this stage, even in internal flooring, so vinyl flooring, these kinds of things. They are also, losing momentum, and people are looking for alternatives, especially inside of buildings.
What is the reasoning for it being banned?
The PVC does have some carcinogenic chemicals in it, and another, I guess, downside is also, burning. So if PVC burns, like chlorine gas comes off, and it's pretty toxic stuff. So that'll just, it's like kill you straight away. It's not really how much smoke you've taken in, it's the poison that you've taken in. So there are a lot of, studies that are out pointing out, carcinogens that exist in PVC. So it's also one of the reasons that Europe is really moving away from it, and one of the reasons that we steered away from using the PVC cap, right from the development standpoint of the product line. Some of the features of this product, again, I spoke about the slip. So the non-slip rating on this is going to be the highest in the industry. The heat buildup is another feature. And then a third feature is this product will get a Class A fire rating, which is also another big one. So after the Grenfell disaster, I don't know if you guys are familiar, but the Grenfell disaster that happened in West London, where I think 83 people died because of cladding that they had put on this tower. It was about a 25-story tower. After the cladding that they had put on there and the system that they had put on, there was a fire that was contained, I think, on the 3rd floor in one apartment. And that fire climbed out of the window and caught onto the cladding and ended up burning that entire building down. It's basically the whole skin of the building set alight. And that was a fire that burned for 27 hours. So 27 hours that building was on fire, through that process. And we are going to get into our cladding products a little bit later, but since I think that was August 2017, the Grenfell disaster, there's also been a massive emphasis in Europe on FR materials, fire retardant building materials. So that's also driven us more and more in this direction. Working with a PVC core, also bamboo fiber reinforced, that gives us a slightly better modulus, so an improved stiffness rating, and also just keeps with our production philosophy of using sustainable products in the manufacture of our items.